All right, so what they are giving us for this one, at time t, the position of a particle moving in the xy plane is given by the parametric functions. We have x of t and y of t. So they're both with respect to time. So we're going to deal with x and y separately. They're both with respect to time. We're given the rate for x, so dx dt is this, and then the graph for y. So it's interesting, they give you a rate for one of them and then just a position function for the other one. If you want to think of like this is velocity and then this is position for x and for y. And then this is 3 line segments shown in the figure. At time 0, the particle is at the position 5, 1. So x is 5, y is 1. Again, we're going to deal with them separately since they're parametric equations. And they do begin time at 0. They don't always start everything at 0. They can start it at whatever time they want. So just be careful with that. If they started at time 12, you'd have to start at time 12. All right, so letter A. Find the position of the particle at time 3. We're going to do x and y separately for this. All right, so let's do x first. X starts at 5, so that's the initial condition. That's where x starts 5 plus, and then we want to accumulate for x from 0 to 3. Time started at 0. We want to find where it is at time 3, and this rate is what goes in the integral. So this t squared plus sine of 3t squared. So that's going to tell us what our x dimension is. So let's plug that in. So 5 plus math 9, 0 to 3, x squared plus sine of 3x squared dx. And it's thinking about it. There we go, 14.377. And again, make sure you do 3 decimal points. So 14.377. Y is going to be a whole lot easier because they actually gave us a position graph for y. We just need to figure out where y is at time 3, which is right here. And so that's -1/2. So that was a whole heck of a lot easier. They gave the position graph for y. So where is y at times 3? Well, you have the point 3, -1/2. So -1/2. So this would be 14.377, comma, -1/2. So your final answer there. All right, letter B. Find the slope of the tangent line. Okay, that means derivative. Find the derivative of the particle at time 3. So that is going to be dy dt over dx dt. We're going to evaluate that at time 3. So dy dx, it's your derivative of y over your derivative of x. They're both with respect to time. All right, so let's do the derivative of y at times 3. So all we have is this position graph for y. At times 3, we're using this line segment, and derivative means slope. So we want the slope at 3. Derivative means slope. So that slope is 1/2. It's going up 1 over 2. So dy dt is 1/2. And then we want dx dt at 3. Well, they gave us dx dt. All we have to do is plug in 3. So 3 squared is 9. And then here, 3 squared is 9 times 3 is 27. So sine of 27. You can type that in the calculator if you want, since it's a calculator problem, but I wouldn't bother because it's a timed exam and that's a perfectly acceptable answer. So I would just leave it alone. All right, so again, it was derivative. So from the graph, derivative means slope. That slope was 1/2. Here they gave us dx dt, so we just plugged in 3. That's the time value they were asking for. All right, part C says, find the speed of the particle at time 3. All right, this is a matter of just memorizing this formula. If you go to the stuff to know sheet under the vectors and the parametric equations, I have all this on here. Part C, and I think part D is asking for total distance. This is a matter of just memorizing the formulas for speed and total distance. So for speed, it's this big old square root, and it's x prime of t, which they want this at 3. So x prime of 3 squared, and then plus y prime of 3 squared. So again, that's more than anything just a matter of memorizing that formula and then filling this in. So we want x prime of 3 squared. X prime is dx dt. This is x prime, that's the derivative. You just have to plug in 3, which is exactly what we did in the previous part, in part B. So if you plug in 3, you get 9 plus sine of 27, and that's, again, getting squared, plus, and then we want y prime of 3, which again, we did that in the previous problem as well. The derivative at 3 was a half, so this would be a half squared. And again, you don't have to do anything to that. You can type it in the calculator if you want, but it's not necessary. So I wouldn't. Because if you button push something wrong, then it's going to be wrong. All right, and then total distance, it's actually a lot the same as this from 0 to 2. You're going to do the integral from 0 to 2 of this. You're just not plugging in the 3's. All right, so it's going to be integral from 0 to 2, big old square root, x prime of t squared. Sorry, too many parentheses there. Plus y prime of t squared dt. Let's forget to put the dt on those ones because it's such a big square root. The issue with this one is we're going to have to break it at 1, not because of the dx dt or anything. That's fine. It's because at 1, particle y, not particle y, the y dimension of this particle, the y parametric equation changes slope. The slope from 0 to 1 is -2. The slope of this line is -2. And then from 1 to 2, it changes to 0. So this y prime is different on this interval and this interval. So we're going to have to separate this and split it at 1. So we're going to do from 0 to 1 and then plus from 1 to 2. So this is going to be integral of x prime squared, which this is x prime, or dx dt. So t squared plus sine 3t squared plus, and then again, for 0 to 1, this slope is -2. So the dy dt is -2 on that interval, right? dt plus, and then we're going to do from 1 to 2, and it's going to look practically the exact same. The only thing is the -2 is going to change to a 0. That slope changes to 0 there. Otherwise, I'm just copying this over. And so because that slope, that rate changed at 1, we had to split it at 1. And then unfortunately, you do have to type this in the calculator. Like this one we could leave alone because that was it. Once you get down to something that doesn't have variables anymore, like it's just numbers, then you can stop. But these integrals still have variables in them. So we are going to have to actually type this in, which was a bummer. All right. But here we go. Math 9, we're going to go from 0 to 1, gigantic square root, parenthesis, x squared plus sine 3x squared, close the parenthesis, that squared, plus -2 squared would be 4. I'm just going to go ahead and put 4 for that, dx, plus, and then another math 9, from 1 to 2, gigantic square root, and then just typing this. And then it's plus nothing, so I'm not going to bother writing plus 0, dx. All right, 4.349. And again, I would truncate. I think that's easiest because, here you have to deal with rounding that. I guess it would be 0.350, but I would just leave it like that, 4.349. All right, so let me go over the points for this one. In part A, it is a point for using the initial condition. So if you wrote 5 plus something, you got a point. It was a point for this integral, and then it was a point for that final answer as a coordinate point. All right, part B, that was just worth 1, which I guess is fair. We didn't really do much there. Part C, you get a point for, I guess, basically knowing the formula, setting that up, and then a point for plugging in 3. And then here you get a point for setting this up. So again, just basically knowing that formula, a point for splitting it into the 2 different integrals, and then a point for the final answer.